So I want to talk to you about the twins paradox as formalized or digitalized into the theorem proof at Lean 4. So this was actually part of a bigger talk that I gave, which I'm going to kind of break down into smaller talks. The twin paradox is a theorem or a paradox kind of that happens in special relativity. Special relativity, of course, made by Albert Einstein in 1905. And what does the twin paradox say? So, twin paradox, let me get my pen. Let me try and annotate. I just changed the color of the box. Okay, so the twin paradox says if you have a point here and you've got two twins, A and B, shows how bad I'm writing with my trackpad on my iPad, on my Mac rather. And twin A basically goes from this point to a point up here, whilst twin B goes via a different point over here and then back to this point. Then, so this is time in this direction, and this is space in this direction. Then when A and B meet at this point here, B will have aged less than twin A. And this happens in special relativity. Something that occurs. And I'm going to prove to you that this happens using a theorem prover called Lean. So let me get rid of this. Let me delete it rather, and then get rid of it. So what is a theorem prover? A theorem prover is something where you can write down mathematical definitions and write down mathematical lemmas and results and theorems, and it will check if they're correct or not. It will do something called type checking to see if what you've written is mathematically correct. And I am making a project called PhysLean, which is a large repository, open source repository for results digitalized, physics results digitalized into Lean. So I kind of want to show you this file which contains the twin paradox. So the first thing in this file is this structure, which is basically a type that has a number of fields. Okay, and this is kind of the data that the twin paradox has with some sort of conditions. So the first bit of data is the start point, and that's kind of that point where twin A and B started at. And this is a point in four-dimensional spacetime. This three here basically tells us that we're working in 3 dimensions of space and 1 dimension of spacetime. This endpoint is the point at which the twin A and B met at the end, and twin B mid is the point where twin B goes off to and then comes back to. And there are some conditions, and these conditions basically say that the start point closely follows the end. The end point closely follows the start point. The point that twin B travels to closely follows the start point, and the end point closely follows the point where twin B goes to. And this is basically saying that yes, twin A can get from the start point to the end point without traveling faster than the speed of light. Twin B can get from the start point to the midpoint and then to the midpoint to the end point without traveling faster than the speed of light. So in Lean, this is a type, and it knows what all of these things are. In PhysLean, there's a definition of space-time. So you can hover over this and it will tell you what space-time is. And if we were on Visual Studio version of Lean, you could click this and it will take you off to the definition of space-time. Same with causality follows, etc., etc. So given this structure, we're gonna call an instance of this T. So this T here has the data of a start point, an end point, and a midpoint in it. We can start to define other things. So we can start to define, for example, the proper time that twin A experienced. So what is the proper time? The proper time is saying that this is the time that twin A experiences when traveling from the start point to the end point. So it's the time that would pass on a watch if twin A had a watch. And this is defined using this generic function that we have in PhysLean called called proper time, and then this space time is just a you know, opening tag, an opening namespace of proper time. So the proper time that twin A experiences is the proper time between the start point and the end point. And we can hover over that, and it will tell us that this function gives us the proper time. And this is all formally verified, and this R tells us that this proper time is in fact a real number. And then we can find the proper time for twin B. So this is the proper time from the start point to the midpoint, or the point where twin B travels to, and then from the midpoint back to the endpoint. And we're here assuming that twin B travels with instantaneous or like infinite acceleration. In other words, they travel at constant speed between all the points they go from and to, and this is the same with twin A. You can do a more rigorous formulation of the twin paradox where you take account of acceleration. The conclusion basically becomes the same thing. So let's do an example where we actually define one of these structures. So we can define an element of this type instantaneous twin paradox, where the start point is at 0, the end point occurs at time 15, but at position 0. The midpoint, where twin B travels to, is at half the time, so at time 7.5, and then they travel to x-coordinate 6, and then back, they'll travel back to x-coordinate 0 at the endpoint. And then we have to prove that the endpoint causally follows the start point. And we do that using what's called a tactic proof in Lean. So this is a series of tactics that we follow. So this is kind of the statement that we have to prove. And then we can, for example, simplify that statement, which reduces it down to some condition about interior and future light cones. And we can take this gives us an or condition. So there's an or, so we can either prove this or prove this. We tell Lean that we want to prove this one. And then we simplify further, which gives us this statement here. Basically says that the course of character of this thing is time-like. And then we kind of show that the course of character is time-like if this is true, if its norm squared is positive. If the Minkowski norm is positive, we write the Minkowski form in terms of coordinates, and then we simplify, and that proves it. So Lean checks that this proof is correct. There is definitely absolutely nothing wrong with this proof. Spare any unsoundness properties in Lean, which we're pretty sure that isn't. So kind of Lean makes sure that we're not doing anything mathematically incorrect here. And you can kind of show the same is true for twin B, the midpoint of twin B, coarsely follows the start point, and the proof kind of follows exactly the same sort of calculation. So we can start to prove some lemmas. For example, that that in this example, the proper time of twin A is 15. So we can write this as a lemma. Naively, you would call this a calculation, but really this is a lemma. And yeah, you can show that the proper time of twin A is 15. And you kind of do this just by simplifying this expression, and you get the answer. You can also show that the proper time of twin B is 9 in the units that we're working in. And this is kind of done by simplification and then showing some stuff about some numbers and then basically just proving the theorem. We could try, for example, norm number as a very automated tactic. So that would simplify this expression to this here, which doesn't quite work because it doesn't want to take this square root and doesn't want to take that square root. But you can see that, these tactics can be quite powerful in proving your theorems. And then the age gap between the two is 6. So this is basically saying that during this journey, twin A aged 6 more years than twin B, which is a fun statement. And this is basically done by simplifying the two ages an age gap, and then using the fact that these are numbers to complete the proof. So yeah, this is kind of a fun example of a proof that's in this project PhysLean. Yeah, it's kind of the moral of the story. I should say that you can access this this code on either by going onto live.physlean.com and linking to the twin paradox file in the PhysLean project, or you can go to my website and go to josephtooby-smith.com/slides/bath2025.html and go to the twin paradox, thing, and you'll see these slides with this this interface where you can interact with it. So hopefully this has been an okay video. Sorry about my voice, slightly recovering from a bit of a, sore throat and cold, and slightly congested. So I apologize for that. And hopefully you've got something from this video. Feel free to ask questions, and it'd be great to have you involved in this project if that interests you.